Welcome back to Agronomic Bites, an educational series brought to you by Taurus Agricultural Marketing, where we break down the crop science behind better fertility decisions. This week, we are talking about one of the most important and often overlooked stages of the season, grain fill. By this point, the crop may look like it has already done all of the hard work. It has emerged, tillered, flowered, pollinated, and set seed. But the story is not over. What happens next can determine grain size, test weight, quality, and, the most important part, final yield. After pollination, the plant begins shifting energy into the seed, pulling nutrients from leaves and stems as it moves toward natural maturity. But what if we could support the process, keep the plant greener longer, and help it keep building yield when every extra day matters? Let's get into it.
Mid-season in a healthy cereal crop, looking out across the green rows, it seems like the heavy lifting is over. But underground and inside the stem, the plant just shifted its internal priorities. Think of a cereal plant like a biological manufacturing facility. The leaves and stems are the factory floor, using sunlight to churn out energy. The developing grain heads, that's the warehouse. Your total yield and ultimately your profit depends on one factor: how long you can keep that factory floor running before the plant naturally powers itself down. The moment a cereal crop pollinates, its only biological goal is reproduction. It moves away from maintaining the plant and focuses entirely on packing that seed warehouse. To do that, the plant makes a calculation. It shuts off the energy supply to its root system and begins cannibalizing its lower leaves, stripping them of nutrients and surging everything upward into the grain head. Agronomists call this senescence. It's a form of programmed cell death, where the plant is biologically designed to kill itself to reproduce. Achieving a heavy harvest is a race against senescence. To maximize your yield, you have to delay this biological shutdown and keep the factory alive just a little bit longer. Looking closely at the upper anatomy of the plant during this window reveals the two key players: the flag leaf and the long section of stem directly below the head, known as the peduncle. As the lower parts of the plant die off, the flag leaf and this peduncle act as the final conveyor belt. They are the last green tissues responsible for transporting every ounce of energy into the seed. Right around the time yellow anthers appear, a microscopic change happens inside the seed. The plant starts forming structures called amyloplasts. Amyloplasts are essentially storage boxes for starch. The plant needs massive amounts of energy flowing from that conveyor belt to physically build these boxes and then pack them tight with carbohydrates and protein. This right here is the biological bottleneck. If the factory loses power too early, those amyloplast boxes sit empty, resulting in lightweight, physically small seeds that hurt your bottom line. This is the specific problem Active Grain Fill solves. It's a 10-0-14 foliar fertilizer designed to act as the fuel that keeps the factory floor open. The precise dose of nitrogen and potassium maintains this stay green trait. By feeding the flag leaf directly, the plant doesn't need to cannibalize itself quite so fast, allowing photosynthesis to continue for extra days. Meanwhile, the potassium, sulfur, and amino acids act as a defense system. They regulate the plant's stomata, or breathing pores, ensuring they stay open and functioning even under environmental stress. To make sure that energy actually makes it to the warehouse, the formula uses kinetin and trace elements like boron and iron. These effectively lubricate the peduncle conveyor belt, accelerating the transport of nutrients into the grain head. It's also built for convenience. Because it's tank mix compatible with most fungicides, you can spray it perfectly during anthesis or milk stage without extra passes. Deploying this nutrient profile at this exact time overrides the plant's natural shutdown sequence, buying those critical extra days to pump weight into the grain. So, what happens in the field when you keep that factory open just a few days longer? This research from AgQuest shows the impact on wheat. An application at the anthesis stage resulted in a 5.2 bushel per acre yield increase and a 1.2% boost in protein. Real-world results from a Saskatchewan barley grower showed improved standability and stronger straw, making for much easier combining at harvest. But the most significant proof was the density. The treated barley reached a bushel weight of 49.6 pounds, compared to 38.9 pounds in the untreated control. These heavier weights prove the agronomic theory. The plant stayed productive long enough to pack the amyloplasts with starch before the season ended. These density improvements extend to other crops too, like oats jumping from a grade 4 to a premium grade 2 in field comparisons. Yield is realized in these final weeks. It requires having nutrition available to pack physical volume and internal weight into every individual seed.
And with that, we wrap today's episode of Agronomic Bites. The key takeaway is simple. Grain fill is not just the end of the season. It is one of the last major opportunities to influence yield, quality, and ROI. By supporting the plant with targeted late-season nutrition with active grain fill, you can help delay senescence, protect photosynthesis, and keep the crop working longer when every extra day matters. To learn more, visit www.taurus.ag.